Now question 25, management accounting. This is a management accounting question that has previously been set, and we want to see if we can solve it nicely. Let's see if we can solve it nicely by applying the regression techniques as explained in data analysis. Farmgate Company Limited produces and sells shovels. The company provided the following data for quantities of shovels produced and the related production cost for the calendar year 2021. So we have months, quantity produced, the production. Then January to February required. Determine the variable cost per unit and the total variable costs using the regression analysis method. B, estimate the total production cost if the following number of units are produced, 100, 150, and 200. They want you to include the upper boundaries and also the lower boundaries. Prepare a chart plotting the predicted Y versus the actual Y from the regression function determined in A above. Then interpret your answer. So we want to do the solution, but before we do it, even without using the analysis toolpack, some of those things can be obtained using what I've explained or things that you see here. You have the slope, you have the intercept, you have the line nest, which gives you both slope and intercept, and we have the R-square function that can help you to get correlation coefficient. So we start with the first one, slope. You can see where I clicked G9. So do it on G9. G9, get the slope. A slope is like B in the equation. B in the equation. So equal sign slope, tab, equal sign slope, then tab. Non-Y's. Now Y is the dependent variable. In this case, the dependent variable is production cost. So select the entire of the production cost from 18 million to 36 million that way. So that is non-Y's, non-Y's, then comma. The other one is X, the non-X. Now select from 150 all the way to 350. From 150 all the way to 350. Close the bracket, and that is slope. Enter. So what is the slope? 95.1721. That is the slope. We can get the fixed cost, which is the intercept. So equal sign, then intercept, tab, intercept, again non-Y's and non-X. Start with Y from 18 million to 36, 18 to 36, comma. Then from 150 all the way to 350, 150 to 350. Close those brackets and enter. Now the fixed cost is 3,977,000. That becomes the fixed cost. And the last one is leanest. So we want to do the leanest. So equal sign, leanest. Do you have leanest? Some versions of Excel don't. And even if they have, some of them only give you one item. So if viewers will give you one item, it's okay. Unatumia ya kitambo kidogo kama 2016. So non-Y's will be from 18 to 36 again, same way of selection, comma. Then the non-X will be from 150 all the way to 350, close bracket, enter. And what is our, that one gives you leanest or linest, gives you both slope and intercept. That one will give you both slope and intercept. Both slope and intercept. If it gives you one, it's okay. Maybe because your version is 2016 and earlier. But if you're using 2019 and latest, then it should give you two. So it gives you both this and the other one, which are up there. Who got one? Okay, it's fine, it's fine. You just need to maybe get a current version of the same. Now we get the correlation coefficient. A correlation coefficient, we use the RSQ. RSQ, that returns the square of the product moment correlation coefficient. Correlation, this one is the square of the product moment correlation coefficient. Is that the same as RSQ, is RSQ the same as correlation coefficient? Because this returns the square. Let me see if we have correl. Just a minute. Yeah, this one returns the correlation coefficient between two data sets. So there is correl, there is RSQ. Which one is which one? Okay, let me see if I'll get the same answer. So I start with the RSQ tab. So non-wise from 18 to 3 to 36, comma, non-X from 150 to the last one. So we are getting that R square is 0.95. That is the R square, the correlation coefficient. What if I use correl? Let me see if the answer will be the same. Returns the correlation coefficient. That is correl. Correl. I start with the, now this one has array 1 and array 2, but 18 to the last, comma, then quantity to the last, and close bracket and enter. So the answers are different. And I believe this is the square 14 raised to power 2, 0.957. So which one is the best one? I think we have done something wrongly and we need to change that. So here we should be using, if we want correlation of coefficient, this one, let me put it here. Tutoe hapa, you can change. So correlation coefficient use the Pearson function. Pearson function. So grab a few things. Use the Pearson function for correlation coefficient. Pearson function. Pearson function. Then equal sign Pearson returns the product moment correlation coefficient R. So we use the Pearson function. And now start with the production cost. The array 1 is production cost, comma, array 2 is the quantity produced. So close bracket, enter. So that is the Pearson function, gives us the correlation coefficient. Then RSQ gives us the square. So this will give us the square of correlation. The square of correlation coefficient, the square of correlation coefficient. The square of correlation coefficient. RSQ. So you also do RSQ function. Non-wise, comma, then non-X as well. Non-wise and non-X, close bracket and enter. So you can see this is the square of the Pearson's product moment correlation coefficient. Same to correl. There's also the correl. You can also do the correl function. Correl function. Same thing. The square of, we can try, maybe I confused again. Returns the correlation coefficient. I think this one will give us the same as the Pearson. Correl. Let me check. This will give us this, comma, and also the other one. Let's see where the error is. 0.97 gives us the same as above, the Pearson. Pearson. So I will take this down, cut, paste. Then I also cut, paste, and this one will also be cut and be paste. So this is same as what you have up there. You can adjust. Yeah. So slope, you use the slope function, that is B. Intercept, you use the intercept function, that is the fixed cost or A. Then you can see leanest gives you both B and A. Then you can see Pearson for correlation coefficient. Correl also is for correlation coefficient. RSQ is for square of product moment correlation coefficient. This one will give us B. This one will give us A. Both. This one will give us both B and A. Both B and A. Both B and A. This one here will give you R. R. That will give you R. R cannot be written like that. So this will give you R. And the other one will also give you R. Then this one will give you R square. R raised to power 2. That is R square. R square. So if you have a question.
Yeah, I have a question.
Yes. Determine the variable cost per unit and the total variable cost using the regression analysis method. And here, just be there and go to data. Click on data. Click on data. Then you'll see data analysis, right? Data analysis, the one that we've just added. Data menu, then go to data analysis. Yeah. Now we are on data analysis. Scroll and find regression. Scroll until you find regression. You will see regression among those items. Click on it and then OK. That is it. That is what appears. Now be keen on what we want to select. This thing has regression, then input, where you do the input Y and the input X. There's a place for labels. Constant is 0 is there. Confidence, there is output, where you want your answer to be. Then we have residuals. So we need to be very keen as we select every element of what appears before us. We start with the input, Y range. You know Y. Between quantity and production, what is Y? Between quantity and production, which one is the dependent variable? What depends on another one? On quantity produced. So production cost depends on the quantity, and therefore it's the dependent variable, and it's Y. So under input Y, where the cursor is blinking, select from the word production cost, as you see it, from the word production cost all the way down to 36 million. Now, I selected from E6. Remember, it is E6 all the way to E18. The dotted lines can tell you what I selected. That is input 1. So again, for input X, select from quantity produced all the way to 350,000. Now, since in our selection, we included the titles of the data, that is quantity produced and production cost, then you check the labels. Make sure that you check the labels. You only check the labels if in your selection for the input Y and the input X, you included the quantity produced and production cost. That is when you pick the label. So I'm picking the labels. But if you had not selected the titles, you just started from 18 million to 36 and from 150,000 to 350,000, then you don't check labels. Labels stands for the headings of your data, and you saw us selecting the headings of our data. Now constant is not 0, so achana na constant. Don't click on it. It's not 0, so don't check here. Leave it. Confidence by default is 95%. Unless you want to change it to a different one is when you mark here. But by default, the confidence interval is just 95. So just leave it. Output is where you want your answer to go. Do you want it to go to a new workbook, to a new worksheet, or a selection in the current worksheet? So you want it to go to a place in the current worksheet. So click on output range, where you see output range. output range, then here, where my cursor is now blinking. Now scroll. Now click on cell C33 on my data, on where my solution is. That is where the result will come. That you can see cell C33 is here. The dotted lines can tell you where I clicked. Then that is the output option. We went for the output range. We don't want a new worksheet. We don't want a new workbook. It's going here. Residuals. Residual means some other things that you can include. Do you want the residuals? Only the first one. Residuals. Standardized residuals, no. Residual plots, you don't want any plot. You want a line fit? Of course, you don't want a line fit unless they ask for them. For now, we're just going for residuals. They'll give us the predicted Ys. If you pick this, then they'll give us the predicted Ys, which is what we want. Then click on OK, and you are done with the first part. That way. If yours has not, you can see the result of the regression. There is the summary output starting with multiple R, R square, adjusted R, and the observation. There is an over. Then there is the place for coefficients. Then there is the residual output. All of them have been brought as our answers in that final result. Therefore, once we've looked at all this, the question said that determine the variable cost per unit and the total variable cost using the regression analysis method. Now the thing is, what is the variable cost per unit? By the way, what is the variable cost per unit? From what we've run, just do an equal sign. Do an equal sign and go to your ANOVA. Not ANOVA, but coefficients. You see under coefficient, there is 95.172. Click on it. That is the variable cost per unit. There it is. What is your fixed cost? From what we have here, what is the fixed cost? Our fixed cost is 3 point. That is 3,977,635.783. That is the fixed cost. Pick it. Then, the intercept. Then total variable cost, they want total variable cost for the entire period. You see, we just have variable cost per unit. What about the total variable cost that they asked about? That is why we have this table. Now, this one did not come with the results up there. This one was there, created initially. And we use this to get the total. We get variable cost per month, then total variable cost. Now, if variable cost per unit is 95.172 per unit, and you did 150,000 units in January, then what is the variable cost in January? Equal sign. Equal sign. Click on the units in January, which is 150,000, times 150,000 times, then click on the variable cost per unit here and lock it. Lock the 95.172. Variable cost in January, that will be equal sign 150,000 times, then click on this variable cost per unit and lock it with absolute cell referencing. With absolute cell referencing. Enter. Drag down. Because we locked up there, just drag to December and get the total. Get the total alt equal and then enter. 231 is your answer. Now remember, we locked the variable cost per unit. If you don't lock, your answers may not be correct. Then you can give that answer, you can copy and paste the answer there. I prefer just doing equal sign because it comes with a formula everywhere. Every time something changes, it also changes on the answer. Then you click on 231. That completes part A. That completes part A. So estimate if you have 100,000, 150, and also 200. Now they want you to include both 95%, lower and upper 95% confidence intervals. Now, what is slope? We just pick slope from our regression data up there. It's constant. So we'll do a constant thing. Pick it from here. The slope, use where you see coefficients. So that is the slope. Then lock it. Enter. So 95.17, it's okay. I truncated the results on that particular cell, but it's the same thing. Yes. So that is the slope, it's constant. Fixed cost, same thing. Fixed cost, same thing, equal sign. Then click on what we have here as 3 million, then lock. Then enter. Enter. This way. So that is the fixed cost. The fixed cost. The fixed cost. Now, lower boundary and also upper boundaries. Lower boundaries and also upper boundaries. Start with the lower boundary. What is the slope in the lower boundary? It's given still up there. Equal sign. The slope in the lower boundary is 81. I hope you can see 81. This is the slope in the lower boundary. You see lower 95. So the slope is 81, then lock, enter, then drag. Fixed cost at lower boundary, go back. Fixed cost ndio hii 916,000. At lower 95, lock it, then enter. Okay, see, we are avoiding total cost because we'll be doing that last. Now try for upper, slope, upper boundary. Go to where you see upper, the 109, upper. I hope you don't have different answers. Fixed cost at upper. Fixed cost at upper, you can see 7 million. Lock, then you enter. Then that is what we have as our answers. To get the total cost, we'll say that our total cost, this way, total cost up there is equal to A plus then BX. A plus BX, like that. That one will give us the total cost. Y is equal to A plus BX. A plus BX. Y, or total cost, is equal to A plus BX. So total cost can be abbreviated as Y, like that. So Y is equal to A plus BX. Now, total cost Y, which is Y, is equal to A plus BX. You simply do A plus BX. So equal sign. Equal sign. What is A in what we have here at base level? A is this, the 3 million. 3 million. Plus, then open bracket, you must open bracket because we are multiplying two things before adding to the cost, the fixed cost. Plus, then multiply B and X. Now, B is the slope times X is the units produced. So units produced, then close bracket, and that is all. So fixed cost is the blue one, plus open bracket. The red one is the slope, the 95.17 times the 100,000, which is C102. Close bracket and enter, then drag down. Drag down. I hope you are not using 100,000 as it is. Those are the answers. Move to lower, here. Again, equal sign, the formula is the same. Then fixed cost is 916, where there is 916. Plus open bracket, BX, click on 81, the first 81, times, now where do we get the X? X remains 100,000. So you click on the one on the far left. That one doesn't change. And you're still going to use this. That one. Then close, enter, drag down. Close, enter, and then drag. And drag. I hope you have those answers. Finally, unless you have a wrong one, total cost on the last one will be equal sign. Fixed cost is 7 million. Click on that 7 million times, open bracket. The slope is 109, the one that has 109.31, then times. The X remains the same. So again, you just click on the 100,000 on the other side. Close bracket and enter. Close bracket and enter. And I'm seeing a very funny answer.
You have multiplied.
Multiplied, so it's multiplied, so it's plus. Good, thank you. That's an attentive student. So that's what we get on that part. I hope you can see that we've predicted the cost given the base coefficients, the lower boundary coefficients, and also the upper boundary coefficients. I want us to prepare a chart plotting the predicted y versus the actual y from the regression function determined in A above. Then perhaps you can also be able to interpret your results. So they just want a chart, predicted y versus the actual y. Now, what is the predicted y? Remember we have predicted y, we also have the actual y. Now, predicted y, just do an equal sign. Just do an equal sign. Then move up to your, you see your residual output. Where there was residual output, there is predicted production cost. The middle column talks about predicted production cost. Click on the first one, which is 18 million. That is predicted production cost. So if you expand that column, you will see that it's written predicted production cost. We'll try that. The column is here. You just expand it. You will see predicted production cost, as I said earlier. Yes, you enter. Actual cost is the one that came with the question. You know, the one that came with the question, those costs that came with the question. Just do equal sign. Equal sign. Actual costs, they are here. The one that came with the question itself. You can move up and use the one that is here in the question. The beginning of the question, it's here. The 18 million, 14 million, and the rest. Those are the ones that came with the question. Drag down. That is all. Now they want a chart of predicted and actual. Predicted and actual. Select the entire data. Select the entire data. Go to insert. Go to insert, then go to recommended charts. Under charts, go to recommended charts. Insert, then under charts, go to recommended. I'm going for the first one. Looks good. Looks just good. Then okay. Yes. So prepare a chart plotting the predicted versus the actual y from the regression function, and then interpret your results. We have it there, and I want to paste it up a candle. There it is. That's our chart. If you don't have a chart, edit the chart a bit by including things like title, only title, and perhaps grid lines. I usually go for, or you can leave it the way it is. Now the axis title, this is months. This other side we have cost. Production cost, then here actual or predicted versus actual, predicted versus actual production cost versus actual production cost as our title. So that is predicted versus actual production cost. Then comment, interpret your answer. So if you want to interpret, you simply say that both predicted versus actual production cost are increasing steadily. They are both increasing steadily. That's what we can see here. They're increasing. Look at that curve. They are increasing steadily. From here, here, they are just increasing steadily at the same rate. So both predicted versus actual production cost are increasing steadily. So both of them are increasing steadily. That is the end of our question, where we've been able to apply the regression analysis toolpack, especially the analysis toolpack using regression in a very, very practical question.